Level 1. The Troposphere. It's where all weather happens. Hot air balloons fly and birds soar. The air is thick with plenty of oxygen, but things get bad real fast. At 10,000 feet, the pressure drops, causing headaches and dizziness. Temperature drops 7 degrees Celsius every kilometer you go up. At 18,000 feet, you lose awareness, pass out, and eventually suffocate. That's why hiking Mount Everest is so dangerous, and why climbers need oxygen tanks. The Tropopause. If you've ever peeked out of an airplane window, that's what the Tropopause looks like. The Tropopause marks the end of weather because warm air below can no longer rise. Water vapor drops off dramatically, and the air becomes very dry. This is where commercial jets cruise. Remember that term loss of cabin pressure? The air density here is only about a third of sea level. That's why airplanes artificially raise the pressure inside. Otherwise, oxygen would rush out of your blood instead of in. The Tropopause shifts up and down with the seasons, as changes in the sun's heating make air expand in summer and shrink in winter. Level 2. The Stratosphere. The stratosphere is a warm level because the ozone lives here, absorbing UV radiation from the sun and converting it into heat. The sun looks brighter here because there are fewer molecules to scatter sunlight. At 63,000 feet, you hit the Armstrong limit. Remember how water normally boils at 100 degrees? At the Armstrong limit, water boils at 37. Saliva on your tongue starts bubbling. Your tears boil. Moisture in your lungs flashes into vapor. In 1966, NASA technician Jim LeBlanc was testing a spacesuit at 150,000 feet conditions before his pressure hose disconnected. He survived only because pressure was restored in time. The last thing he remembered? The saliva on his tongue boiling. The Stratopause. At this altitude, the sky looks pitch black, and stars are visible during the day. The Stratopause contains highly stratified gases, which basically means heavier molecules are concentrated lower while lighter gases float higher. With air density at roughly 1% of sea level, sound waves lose energy very quickly, which makes noise barely audible. The air pressure here is so low that your body starts to behave strangely. Your sinuses rupture, your abdomen bloats, your lungs stop functioning, and oxygen masks stop working. Within minutes, brain damage becomes irreversible. Level 3. The Mesosphere. The Mesosphere is one of the most mysterious regions of Earth's atmosphere, as it's too high for aircraft and too low for orbiting satellites. It's mostly studied by using temporary rocket probes. The Mesosphere contains less than 0.1% of Earth's atmospheric mass. The air here is so thin that even radiation escapes into space. Despite low density, surprising chemistry still happens. Hydroxide, atomic oxygen, and nitrogen oxides all take part in fast-moving chain reactions. Atmospheric gases are now thick enough to slow down meteors. This is where shooting stars slam into the Mesosphere, tiny meteors the size of rice grains. But how can we see them if they're so small? Because they can travel at 260,000 kilometers per hour. The Mesopause. This is the coldest part of Earth's atmosphere. Colder than Antarctica. Colder than most of space. Temperatures as low as minus 100 degrees Celsius. Temperatures are so low that noctilucent clouds form from tiny ice crystals, less than 100 nanometers wide. These clouds glow long after the sunset, creating a beautiful and ethereal appearance in the sky. Beyond this, temperature stops decreasing and starts increasing, as it's the coldest point before the air above starts warming again. The Mesopause blocks a fraction of harmful solar radiation because sparse air molecules absorb and deflect incoming particles. It also marks the first strong interaction with cosmic particles, fast and tiny moving bits of energy that smash into the thin air and break air molecules apart. By now, oxygen concentration is essentially zero, and air pressure is almost non-existent. Your body is no longer a closed system. Tissues expand, gases escape, your blood oxygen crashes, and your organs shut down. Death is fast, silent, and inevitable. Level 4. The Thermosphere. Temperatures exceed 2,000 degrees Celsius. That sounds insane, but you wouldn't burn. Why? Because there are too few molecules to transfer heat. Instead, something worse happens. Charged particles slam through your body. The air here is electrically charged. Gases in the thermosphere are so energized that they act like plasma. This is also where auroras form. Solar particles collide with Earth's magnetic field, lighting up the sky. Most satellites in the ISS orbit here, skimming the edge of the atmosphere. At 100 kilometers, you cross the Kármán line, the boundary where flight becomes impossible and space begins. Only astronauts have passed this line. Level 5. The Exosphere. It's composed mainly of hydrogen and helium. Atoms drift hundreds of kilometers apart, with no clear boundary. Temperatures near absolute zero. Not from the cold, but because it's so empty that there's hardly any particles to measure. This also means that sound can't travel, so you wouldn't be able to hear your own shouts. It's one of the eeriest aspects of near space, complete silence. This level is the first to interact with the solar wind, a stream of charged particles from the sun traveling at 1.7 million miles per hour, which can trigger geomagnetic storms. In the exosphere, your body enters full vacuum exposure. Fluids vaporize and tissues expand uncontrollably. You are exposed directly to space. This is no longer Earth.